Hey everyone, welcome back to another LeetCode problem solving video. Today we are tackling a highly practical interview question that every software engineer deals with in real life. LeetCode 165 compare version numbers. The problem gives us two version strings, version 1 and version 2, and asks us to compare them revision by revision from left to right. If version 1 is greater then we have to return it. If version 2 is greater, we return -1. If they are completely equal, we return 0. Now the tricky part here is that revisions can have leading zeros like 0, 1 and 0, 0, which are mathematically equal to 1. Also, one version might have extra sub-revisions like 1.0.0 while the other is just 1.0. Our code needs to handle these mismatches elegantly. Let's look at our strategy first and we will break down the code. To compare these version strings efficiently, we don't want to split the string into arrays or create heavy extra data structure. Instead, we can use a two-pointer approach to parse integers dynamically on the fly. We will place a pointer I at the start of the version 1 and pointer j at the start of version 2. In each round, we will extract the numeric value of the current revision block up until we hit a dot or the end of the string. Because we build the number mathematically as an integer, leading zeros like 0, 0, 1 automatically collapse into plain old 1. If version if one version string runs out of characters before the other, we will intelligently default its missing revision value to 0. This beautifully handles cases like comparing 1.0 and 1.0.0. We compare the two processed numbers. If they are equal, we skip the dot and move to the next revision. Let's see how this looks in C++ block by block. To begin, we initialize our two pointer indices I and j to 0. We then set up a master while loop that keeps running as long as at least one of the strings still has character left to process. So int I equals to 0, int j equals to 0, while I less than version 1 dot length or j less than version 2 dot length. At the start of every revision block, we initialize two 64-bit integer variables, num1 and num2, to 0. This will hold the numerical values of the current sub-revisions we are about to extract. So long num1 equals to 0, long num2 equals to 0. Next, we use a nested while loop for version 1 as long as our pointer I is within bounds and hasn't hit a dot. We extract the character, convert it to a digit by subtracting the character 0 and add it to num1 and advance our pointer I. So while version sorry, I less than version 1 dot length and version 1 of I not equals to the dot. Then num1 equals to num1 into 10 plus version of I minus 0. We do not we do the exact same thing for version 2 using a second nested while loop. This loop extracts the numeric value for the current section of version 2, handles any reading zeros naturally, and advances our pointer j. So let's do it for the another value. While j less than version 2 dot length and version 2 of j not equals to dot. Okay. So for that num2 will be equals to num2 into 10 plus version j, sorry, version 2. Here version 1 will be there. That's my mistake. 1 2 minus 0. Okay. And then plus 0. Here I forgot it to plus I. Now that we have isolated both division values as pure integers, we compare them. If num1 is strictly greater than num2, we immediately return 1. If num1 is strictly less than num2, we return minus 1. So if num1, sorry, greater than num2, then return 1. If num1 less than num2, then return minus 1. If they are equal, we don't return anything yet. Instead, we increment both I and j by 1 to skip past the dot characters we just stopped at, and the master loop goes to the next section. If the loop completes entirely without returning 1 or minus 1, it means both version numbers are perfectly identical, so we return 0 plus I plus j. Sorry, we have to write this in the while loop. So that's it. Okay. Now it's okay. Okay. So then after we will return 0. Now let's run and check whether this is working properly or not. Okay, sorry. Okay, that's working properly. Now let's try run this. So now let's try run with a classic text case to see how it ignores leading zeros and handles unequal lengths. Now version 1 equals to 1.01 and version 2 equals to 1.001. So now round 1, I will be equals to 0 and j will be equals to 0. Master loop enters, this loop starts. Okay. Now version 1 loop passes until the dot num1 equals to 1. I stops at index 1. Version 2 loop passes until the dot num2 equals to 1. J stops at index 1. Since num1 equals to num2, sorry, num1 of 1 equals num2 of 1, we don't return. We execute plus I and plus j to skip the dots. Now I equals to 2, j equals to 2. Now round 2. Now we are looking at the next block. Version 1 loop reads 0, then 1. Num1 equals to 0 into 10 plus 0 equals to 0. Then 0 into 10 plus 1 equals to 1. So num1 equals to 1. I reaches the end of the string. I equals to 4. Version 2 loop reads 0. 0 then 1. This mathematically evaluates to num2 equals to 1. J stops at the dot, j equals to 5. We compare num1 equal num1 of 1 equals num2 of 1. Still equal, we skip the past dot, I becomes 5, j becomes 6. Round 3. The master loop runs again because j is still within bounds of version 2. Since I is out of bounds, for version 1, its nested loop skips entirely, leaving num1 equals to 0. Version 2 reads the final 0. So num2 equals to 0. We compare num1 of 0 equals num2 of 0. They are equal. Pointers move forward. Now both pointers are out of the bounds. The master loop exits and the function returns 0. The versions are correctly identified as equal. So this is the try run. Now let's submit the code and check whether it is passing all test cases or not. Okay, so our solution is perfectly passing all the test cases. Now let's discuss about the complexity. So for time complexity, we are scanning through each version string from left to right exactly once. Every character is visited a constant number of times. Therefore, the time complexity is linear, that is order of n plus m, where n and m are the length of version 1 and version 2 respectively. Now space complexity. Now here you notice that we are not creating arrays storing substrings or utilizing any dynamic memory containers. We are simply keeping track of a few primitive integer pointers and numeric variables. This gives us an optimal constant space complexity of order of 1. And that is how we build a rock solid zero allocation version string competitor. It's an excellent showcase of using custom internal token loops instead of relying on heavy regex or string parsing utilities. If this line by line breakdown and structural dry run help the logic click for you, make sure to slam that like button, subscribe to the channel for more clean LeetCode walkthroughs, and let me know in the comments if you have any question. Okay, so keep coding, keep practicing, and I will see you in the next problem solving video.